We're going to talk about a different kind of chemical reaction called corrosion. And it says at the top, read pages 252 to 254. We're actually going to do this. The students who are in class, cohort B, are going to read this in class. And I want you to read this at home too, because there's lots of little tidbits of information which are important there. Anyways, corrosion is the breakdown of a metal as it reacts with chemicals in the environment. So corrosion can be beneficial, it could be good, or it could be bad, like in the example of rust. The first one I want to talk about is beneficial corrosion. So sometimes corrosion of some metals form a tough protective layer that prevents further corrosion. For example, aluminum will react with oxygen in the air and it becomes harder and it prevents anything from getting through. Another example of beneficial corrosion are the copper rooftops of the parliament buildings. So first they start with a small thin piece of copper, and then the copper reacts with the oxygen in the air, makes copper oxide, and it turns green. You can tell a chemical change has taken place because it's gone green. And it actually gets heavier and it's stronger and lasts a lot longer. I believe those rooftops last about 70 to 90 years. And you may say, well, how did it get heavier? Well, we've added oxygen, and it's just the mass of the oxygen. So we haven't violated the law of conservation of mass. So beneficial corrosion is when a metal reacts with oxygen and it becomes tougher and stronger. However, that is not always the case. Sometimes we have something called rust. So rusting is the corrosion of iron and steel that leads to degradation and damage of a metal. Rusting is caused or accelerated by exposure to oxygen. So one of the things we do to prevent rust is we paint metals. Another one is exposure to water. So I know every time we go skating, I take a cloth with me and I wipe the bottoms of skates. I want to dry the skates because if I leave the water drops on there, I know the bottom of my skates is going to rust faster and I have to get them sharpened more quickly. And the last one is exposure to electrolytes. So an example of electrolyte could be salt. And in Canada, in the wintertime, we actually put salt, well, in this part of Ontario, we put salt on the roads, and that actually increases the rusting. So if you go to a country further south, like in the Caribbean, where they don't actually put salt on the roads, the cars actually last a lot longer. They don't rust out like they do here. So there are different methods to prevent or slow down corrosion. And when I say corrosion, I mean rusting. So one is putting protective coatings on it. So you can paint it or put a plastic coating on it or chrome, for instance. A great example is the Eiffel Tower. So the Eiffel Tower receives 50 to 60 tons of paint every 70 years. So they're painting it so the oxygen can't get to the metal and cause it to rust. So if you can prevent the oxygen getting to the metal, it will prevent it from rusting. Another thing people do to their vehicles is they do an oil undercoating. They actually coat the metal with oil, and that's like a protective layer that prevents the oxygen getting to the metal and rusting out your exhaust system. There's other things we can do. We can use corrosion-resistant material like stainless steel. Stainless steel is like it's steel that's been coated in zinc, and that's something most car manufacturers have done. Okay, so instead of having all these exhausts that rust out every year, they've switched to stainless steel and they last much, much longer. Another example could be just plastics. We could put plastic on top of it and that works as well. Another one is galvanized steel, which will last longer as well. So now what I want you to do is just some homework questions out of the textbook. And this was the last topic in Chapter 6. So we're going to do some review questions out of Chapter 6. So once you finish those, I do want you to look at questions 3 to 8 and number 11 on page 258.